Hello again, this is the Martins of Kini Big Deal, and I thank you so far for your attention on this particular topic of indices. And if you've been following all our lessons so far, you remember how we went through all the laws of indices, detailing how to use them. Now, in this video, I'm not going to waste your time. We're going to take a look at some sample questions and see how to approach them. Now, the questions that are going to be presented here are not exactly what you'll always see in your work, but once you have the correct idea, solving them becomes very easy for you. Okay, so the first question we're going to kick off with as soon as I'm done cleaning your local blackboard here is one that actually challenges your knowledge of the first rule. Okay, now I'm not going to clean the rules on this side of the screen so that you can always refer to them and see what exactly is going on. So for the sake of education, we're going to use color red. I'll try and use the colors of each of the laws and see whether it helps aid your understanding. Now, there's a question here that says solve or 2x raised to power 0. Okay, what is the answer to this? Now, if you take a look at this law, you remember I told you that anything raised to power 0 is always 1. So what is raised to power 0 here? Well, it is not 2, it is x. X carries this problem alone, so x is raised to power 0 because this expression really means 2 times x raised to power 0. And any number, including x, y, z, p, 100 million, 200,000, raised to power 0 is always 1. So the question becomes 2 times 1, and your answer is what? 2. Therefore, 2x raised to power 0 is 2 because the whole evaluation here becomes 1, just like the law told us in indices. You can pause the video, go over that again. It's a very simple example. So let's move on to another thing while I clean this off. Okay, we'll do something else now. We'll be growing larger as well. Now, there's another one here. I think this one deals with, let me show you the question first. The question says 5 times 8 raised to power 2 over 3. Okay, take a look at this very well. Which of our laws do you think we'll use for this? Look at it very well, look deeply. Okay, well, if you're paying attention, you'll discover that the 5 is the innocent guy in this case, okay? Our innocent 5, but this is the one that actually has an index. Does this look familiar? Okay. You remember a raised to power m over n, you can see the law right there. So you write your 5 as usual while you deal with this. What does 8 raised to power 2 over 3 really mean? 8 raised to power 2 over 3, okay? Assuming this is your m and your n, like we did in the previous lessons, and you can see the laws here, what you do is you rewrite it. Your a is 8, right? So you say n, which is your 3, root your a, which is 8, then everything what? Raised to power m. Your m is 2, so it is squared. Now, what this question really means is, what will be raised to power 3? Okay? What will be raised to power 3 to get 8? It means what will be multiplied by itself 3 times to get 8. So I can think of it, since 8 is an even number, let's consider the factors. Say 2 times 2 is 4. We're getting somewhere. Times another 2 is what? 8. Wow, that's the 8 we are talking about. So 2 is the number you need to raise to power 3 to get 8. So you can rewrite this one as 2, then squared. Not forgetting the whole thing we are talking about here, still multiplied by 5. So what you're basically doing is 5 times 2 squared, which is equal to 5 times 2 squared is what? Repeated multiplication 2 times 2. Okay, we are raising 2 to the power of 2, which means we are multiplying 2 by itself twice. Okay, so 2 times 2 is 4. Okay, the answer is 20. You can pause the video and go over the concepts. Like I told you, that's the whole advantage of a video lesson, unlike having to disturb your teacher in class. That's a very simple one. Then we move to one of, would I say, okay, I hate to describe things as complex anyway, because once we say something is complex now, you start running away. That's why you stopped classes to start with. But moving on, without looking at your behavior, we'll go over another example, which says 6 into y raised to power 4, okay? Then all this raised to power 5 divided by 12, okay, 12 y raised to power 4, then another y raised to power 5. Take a look at this question very, very well, okay? This is where the problem starts for a lot of people. Now, first things first, to make your life easy, you may want to simplify. There are some things that can go into each other here, okay? If you divide this place by 6, you'll be left with 1, which you don't have to write, okay? If you divide this one by 6, you have 2. So you can modestly write this one as y raised to power 4, everything raised to power 5, divided by 2. Can you remember your 2 here? 2 y raised to power 4, then y raised to power 5. We've made it simpler to look at. Then take a look at this place very well. Okay, this place I'm circling. Okay, does it remind you of any of our laws? Look at log D, the one in green. Okay, I'll solve it with the green color so it can be familiar to you. Now, this whole expression here can be rewritten as y raised to power 4 times 5, because I said if you have a raised to power m, which is our y raised to power 4 in this case, y raised to power 4, then everything now raised to power n, which is outside. What you do is you just multiply the powers. If you remember the bread, tea, and butter example, where you have bread in a bracket, okay, you have your bread like this, it is raised to power maybe butter, then outside it is tea, and we said all join. Okay, so that's exactly the same thing you'll be doing here. Okay, so what you now have is this one becomes y raised to power 4 times 5 divided by 2y raised to power 4, y raised to power 5. You go on rewriting by saying y raised to power 20, okay, divided by 2y raised to power 4, y raised to power 5. Now, some of you that are very quick with arithmetic may find it better to just, skip through the whole thing. But remember, if you're not that fast, just go over it step by step, applying the laws. And from what you can see here, you discover that some of these laws actually, you can have to, you may have to use more than a law in a single question, so far it concerns indices. So we're going to continue solving this one at the top of the board. So what do we do next? Y raised to power 20 over 2y raised to power 4, then y raised to power 5 is the same thing as saying it's the same thing as saying y raised to power 20 divided by, something should be looking familiar now, divided by 2y 4, then y to the 5th power. Now, the same law that we applied to this, if you have y raised to power 4 and y raised to power 5, okay, sorry, I beg your pardon, y raised to power 5, it means, and you have 2 here, what we're basically doing is we are saying 2 times y raised to power 4 times y raised to power 5. Now, don't bring the 2 into your confusion because it does not have an index. But if you remember your law in yellow, okay, that says a raised to power m times a raised to power n is equal to a raised to power m plus n. So look at this now. Y raised to power 4 times y raised to power 5. What do? We add the indices. So this becomes 2 times y raised to power 4 plus 5, okay, which is the same thing as 2 times y raised to power 9, which is the same thing as 2y raised to power 9. So you can rewrite this expression as y raised to power 20, okay, divided by 2y raised to power 9. Now, look at the law C, which is why I'm writing this in white ink. If you're dividing a raised to power m, let's assume this is that, y raised to power 20, divided by a raised to power n, what do? We subtract the indices, okay? We do what? We subtract the indices. So this becomes, of course, you can always write it as, say, y 20 divided by 2y raised to power 9. But the point is, you're going to be subtracting the indices. So what you have will be y20, y raised to power 20 minus 9, okay, divided by 2. So your answer now becomes y raised to power 11 divided by 2, which may be better written as y raised to power 11 all over 2, and that is your answer. Please feel free to go back to the video anytime and play over. We're going to have another video because this is getting too long on more worked examples. Enjoy yourself.